And welcome back. What we had last time was this concept of arrays of a given size. We used a range-based for loop to assign it a value. And what we have to remember, though, is that when we have arrays of things, each individual thing that's inside the array, each indexed item in things, is effectively an integer. So just like if you had an int thing like this int thing, all the stuff that we can do with it, all the addition, subtraction, multiplication, division, whatever you can do with an integer, you can do with an individual element of an array. So if you wanted to increment it by 1, you can do that. You want to decrement it by 1, you can do that. So mathematically speaking, we have no limits on what we want to do. We can even use one element and play with the other elements to manipulate it like that. So the mathematical things you can do with it are just the same as any other integer value we've got. And we've already showed you how you can print arrays and do everything else with that, but this is just telling you that the thing that we've created is nothing more than a group of integers and can be treated individually by index as if it was just a plain old integer. So for example, if we had a function up here that was a void function called print that took an int, and we wanted to write that as a function just to print it, so we could actually come into here and say print a specific thing. So we can print a given thing this way, and it's going to come back and give us the answer of 6. Thing 0 was whatever it was. We set it as 5. We added 1 to it, blah, blah, plus, plus, and we printed it. We can loop through the array with a for loop. We can actually use a for each loop too. Boop. So you can see that every one of these things, since this is an individual copy of an individual thing, we can use individual techniques we used and learned in functions to manipulate each possible variable. Now, something we've done here, though, is we've set an individual item to other individual items in a way that we're used to, because each one of these is an integer. However, if we were to come in here and make things 2, and just do that with it, and if we come down here and we say, okay, things 2 equals things, this right here doesn't have a whole lot of impact. Notice we've already manipulated this thing. If we come in here and we say, okay, let's do a print as of now, what you would expect if this worked was that things 2 would actually get a copy of everything inside things. But if we try to compile this thing, it's going to boom and tell you, hey, look, you can't even do this. The array type int5 is not assignable. The assignment operator doesn't work. So all the stuff that you think might be logically possible with arrays does not work that way. You can't do it this way. If you want to assign everything inside things to everything inside of things 2, you need to go element by element and do an assignment just like we did with this kind of thing here. You need to move them one at a time over to this. So basically, you can't do this. You can't assign things like you do normally arrays to whole value arrays. But they are manipulatable. One of the most common things of all is to say, okay, let me find an average of all the things inside my array. So what's the average of all these values that I've got? Can we do that? Sure, because we have the ability to manipulate everything inside of it. So we would need something to total it up with, of course. And if you want to make it be more accurate, we can actually make this a double, because a double would be more accurate for an average of values. So we can come down here and say, for every element inside things, for every index that we play with, we want to take our total and add it to it. And that would give us a new total. When we come out of it, if we wanted to, we could just print it out. Allow for implicit casting to take care of it, because our size will be converted to a double. And then what we'll get out of this, and I'm actually going to take out the print because we don't need to see that right now. No, it's 0. I thought we initialized it. Turns out I deleted too much there, so if I delete the totaling, it doesn't work. There we go. Our average is 6. So you can see you can find averages very quickly. Again, it's that same concept of running through things on a for loop. If we wanted to find out the smallest possible number, find minimum. Let's say we want to find a minimum. So int min equals 0. Well, the easiest way to do that is, again, use another loop. Use another for loop. And we'll just copy this to show, because we want to go through every element in the array and find out what the minimum is. Now, the catch to this means what you have to do is you have to make sure that your values that you're using in any testing of an array set must be part of the array set. So we want to start inside the array. Could you declare a minimum value equals 0? Sure, but what happens if you have a negative value? Well, could you declare a minimum value to be the smallest possible integer for your compiler and your system? Sure, but that's kind of excessive. So what we normally do is set something like min equal to the array element at the first position. And this means now that our minimum value is currently the first element because we haven't checked anybody else. And then if I want to be slightly more efficient, I can start at 1 because I just used 0 and check to see if the element that I'm looking at inside my array is less than the one I've already picked. Then what I need to do is set my minimum equal to that element. When I finish this loop, having gone through every single element and compared it one at a time, you're only comparing 2 elements at a time, you'll end up with the very possible minimum number value. So if we wanted to, and our minimum value is 4, which kind of makes sense based on all the things that we've been screwing around with. So there you go. You can now run through your value set and find the smallest possible value. If you turn things around, you've got the highest possible value. You've got a maximum value by setting it to equal to 0, and instead of checking for less than, check for greater than. And that gives you the easiest way to start manipulating your programs and your values inside an array. So in this, we've covered average, total, you can't copy stuff, and how to manipulate individual elements, minimum and maximums. Okay, hope you're having a great day.